This is January 2018 multiple choice questions 1 through 5. Number 1. In the diagram below, a sequence of rigid motions maps ABCD onto JKLM. And so that means that A has to map onto J, and B has to map onto K, and C has to map onto L, and D has to map onto M. So in order for this to happen, this figure needs to rotate and then translate on top of JKLM. Okay? So if B goes with K, then this is also 104. And if A goes with J, that makes this 82. And also that makes this 121. It goes both ways. Because the corresponding angles of congruent figures are congruent. And so how do we find the measure of angle M? Well, that's the fourth angle in a quadrilateral. A quadrilateral has 360 degrees. So 104 plus 82 plus 121 plus x has to equal 360. And I add those all up. We get 307. And if I subtract 307, I get 53. Read the question again. What is the measure of angle M? I did just calculate that. The measure of angle M is 53. That's choice 1. Parallelogram HAND is drawn below with diagonals HN and AD intersecting at S. Which statement is always true? Well, you should know that the diagonals bisect each other. So this will equal this, and this will equal this. Okay, that's the first thing. And you know opposite sides are congruent. You may or may not need to mark them. Which statement is always true? Will HN be equal to half of AD? So that means, does HN equal AS all the time? Clearly no, and you can see in the picture that they don't even look like they are. AS equals half of AD. Yes, because the diagonals bisect each other. So it cuts the full segment in half. So I'm going to go with this answer. Angle AHS, and angle ANS are congruent. Those are not alternate interior angles. If they had said this angle and this angle, then I would say yes. But they said this angle and this angle, so the answer is no. And HDS congruent to NDS. Is this angle cut in half? And the answer is no. You can even tell by looking at it. Now, that's not a reliable way to solve a problem, but a little common sense can go a long way when you're looking at the picture and you can see for yourself that that does not have to be true. So the answer to number 2 is 2. In question 3, the graph below shows two congruent triangles, ABC and ABC prime. Which rigid motion would map ABC onto ABC prime? Well, it looks to me like a perfect reflection. You can see, if you look at this first, the pre-image here, ABC, it goes ABC in a clockwise direction. But when you look at the image, it says ABC in a counterclockwise direction. And you have to have a reflection in order to do that. So right away I know I'm looking for a reflection. And would it be over the line y equals x? Which means the uphill diagonal with a slope of 1. And so I'm going to go with 4 because I know I have to have a reflection to change the orientation. of the letters, the vertices. Okay, rotation, translation, rotation, none of those things will do it. Okay, on to question 4. A man is parasailing above a lake at an angle of elevation 32 degrees from a boat. They labeled it nicely for you, as modeled in the diagram below. We know it's a right triangle. We know an angle measure, banking on SOHCAHTOA. This is going to be trig. If 129.5 meters of cable connected the boat to the parasail, approximately how many meters above the lake was the man? So they want to know how high above the lake he is. So across from this angle is opposite. Across from the right angle is always hypotenuse. And then adjacent is next to. So it looks like I'm using opposite and hypotenuse, which is sine. So you have to write an equation. Sine 32 equals x over 129.5. Multiply the denominator away. Now you'll watch some videos, maybe you're ambitious enough to watch some videos on YouTube on this particular question. And there is a young man who puts out a really good video, but I think he overcomplicates some things, which is why I'm taking the time to record these myself. So times 129.5, 129.5. So now your denominator is canceled out, and then you put 129.5 times sine 32 in your calculator. You must be in degrees. I just turned on my calculator. I noticed it's in radians. That's no good. So I have to go to Doc 7 2 settings. Change it to degrees. I'm going to make that the default. Must be I was checking somebody's wrong answer to see if they were in the wrong mode. And I didn't change it back. Okay, so I'm going to try this again. 129.5 times sine 32. And I have 68.6. And that is a choice, and so I'm going to go with that. The answer is 1. Okay, and number 5, a right hexagonal prism is shown below. A two-dimensional cross-section that is perpendicular to the base is taken from the prism. Which figure describes the two-dimensional cross-section? Well, there's two bases. They're parallel and congruent. That's this and this. If we are parallel, if we cut it parallel to the bases, we end up with a hexagon. We don't want to be parallel to the base, so we're going to cross off hexagon. And while you're at it, you might as well cross off pentagon. We can make a pentagon cross section if we hit 5 faces at the same time, which it is possible, but that's not what it's asking us to do. It wants us to go perpendicular to the base. So if I cut straight across here and straight across here and connect these and these and then shade it in, what will that cross section be? Perpendicular to the base. So cross section, that will be a rectangle. For a triangle, you'd have to nip off a corner. We're not doing that.